All right, welcome back. So this is now lecture 2. Let's get right on into it. Let's see if I can make this slightly larger. There we go. So today is about control flow as well as reviewing some data types. Okay, so again, with an iClicker question that I can't actually ask you. So pause the video and see if you can figure out what does it mean to compile a C++ program, just to make sure you've remembered from last time. And so assuming you've now unpaused it and you have your answer, let me circle the correct answer so you can have it forever. Well, it's not writing the implementation. The compiler is doing B. It's converting the program. So it's taking your high-level language and it's converting it down to a form that your processor can actually run. And usually it can run it very, very quickly compared to other kinds of programming languages like Python that are not compiled. Executing the program, there's not any other word for that other than execution, and it's not none of the above. So just B, we are translating our program. That's what compilation means, translating it into machine code. Okay? So now, I've told you about compile time errors last time, but I haven't quite introduced runtime errors, so I'm going to introduce both and then give you this question to think about before I code it up and we see what's going on. So a compile time error is an error that happens when you compile your program. So the compiler is going to spit back out an error for you to see and then fix, and it's going to refuse to compile your program. Your program will not, the compiler will refuse to make an executable program for you in this case. So you won't be able to run anything because it's not going to make any program for you. And this is in contrast to a runtime error. Runtime error is, an error that the compiler can't catch. It's too complex or some other reason. And it happens while the program is running. So it definitely compiled, your program totally compiled, and now you're running it, but oh no, something went wrong and it has to stop. So a runtime error stops the program and it ends it immediately when anything goes bad. That is a runtime error. That will stop the program because it is unrecoverable. All right, so see if you can think about what might happen when your program divides a number by 0. Will it be a compile time error, a runtime error, or perhaps both, or maybe neither? And I guess this isn't a question that I expect you to know the answer of, but I'm going to show you exactly what happens so we can understand it together. You might expect that, oh, maybe the compiler can check for this kind of thing, or maybe it can't, and it throws this kind of error. Or maybe like when you divide by 0, C++ has made it so that the answer is always like infinity or 0 or something like that, and it's not even an error. So let's find out. I have made a lec02 folder, and I will make a new file called divide by 0. divide_by_0.cpp. And remember, you're going to get all this code to look at yourself. So I want to output things, so I'll include the IOStream library. And I don't like using that std : all the time, so I'm going to say using namespace std. And then I'm going to make my main function, which always returns an integer if something goes right. If the program executed successfully, we always want to return 0 as the last thing in our program. So now we have a blank program to work with. And let's make a program that divides by 0. So let's ask the user to enter a number. Cout, please enter a number. And then I won't put a new line so that the user types on the same line. And then I'll make a number for the user to enter in. So I'll make it be called x. And I'll make cin read from the user and fill in x with whatever value you get. So remember that the arrows are going now towards x because the information is flowing from the user's keyboard to the x variable. And that's the opposite from cout, where this string that we want to output to the screen, that information is going this way into cout, which is your screen. your terminal screen, I guess we can say. So now after these two statements have been executed, cin will have gotten this x value, and now we can use x. Now x is filled with a value that we can use. So let's now try to output 1 divided by x. 1 divided by x, and I'll even include a new line, let's say. Okay, so that is my program, and I'm going to compile it and run it. So in order to compile it, I'm going to go to my terminal again. I'm in the code from class folder right now, and inside of that I have these two folders, one for last lecture, one for this one. And I want to move inside of the Lec02 folder now, so I'm going to change directories just like that with the cd command. Now if I do ls to see what's there, I can see these two files. The one I just made and one that I've included from another time, so I've pre-made it. Okay, so let's compile this. We use G++, then the name of our program, and remember you can always type tab to have the terminal fill in things for you, so it saves your fingers from doing too much typing. So please compile that, and don't call it a.out, don't call it that default name, call it divide by 0. That will be the name of our program that we run. Okay, so here it is compiling, and it has compiled. If I do ls, there is my program. It's a different color because it's runnable. So I'll do // because I'm in the current directory and I want to run a program there. So // divide by 0, hit enter, and okay, now it's asking me for that number. Let's see if I can make this a bit smaller. There we go. Please enter a number. Okay, 5. Or no, let's do 0. Let's do 0 for now. And oh man, look what I get. I get a runtime error, in fact. So this program was allowed to compile, but it stopped prematurely with this error message. Notice that I didn't print anything out that looks like this. So that is not good. And if we try some other number, it's not always going to do something weird, but it will output 0 in this case, and we'll talk about integer division later. But yeah, anytime you don't give it 0, it'll do the right thing. Oops, I spelled this wrong. So this causes a runtime error. Oh no. And the reason that it did this, the reason that the compiler could catch this, is because it's not always an error. The compiler didn't catch this because it's only an error when you enter 0. You shouldn't expect the compiler to, you shouldn't even want the compiler to stop this program from compiling, because maybe some other way you will have prevented this x from ever being 0. So that is an issue that is left to the run time of the program. All right, so long-winded answer. This is in fact a runtime error. Okay? And okay, now let's get into the topic that's going to be the running example for most of today's lecture. It's this thing called Fizzbuzz. It's supposed to be a game, and it used to be like a very common interview question, but now it's a little too easy. So here's the game. So we're going to read some numbers, and whenever we get a number, we're going to output either that number, or the word fizz, or the word buzz, or the word Fizzbuzz. So the idea is, okay, here's Fizzbuzz. This is our game. We take a number. I guess, let's see here. How do I want to explain this? So Fizzbuzz, if you give it a number that is divisible by 3, so n divisible by 3, and this is like, you can imagine it's a function that takes a number n. If n is divisible by 3, we're going to output fizz. If n is divisible by 5, we're going to output buzz. And if it's divisible by both 3 and 5, we'll output Fizzbuzz. Both 3 and 5 will output Fizzbuzz as a B. Okay, and otherwise, we'll just output the number n, whatever it was. Maybe it's like 1. We'll just output the 1 in that case. So for example, we'll take the number 1 and output 1. We'll take the number 3 and output fizz. We'll take the number 5 and output buzz. And we'll take the number 15 and output fizzbuzz. Okay, so that is the game. That's the idea. And we're going to get our input from the user in a few different ways. Right now we know how to get input from cin. We're also going to talk today about getting arguments from the main function, from the actual terminal itself. And then files will be left to a later lecture. So, yes. And you can also write to a file if you want to output things. But we're not going to talk about that today either. So, let us code our first version of Fizzbuzz. And this is a simpler version. So Fizzbuzz 1.0 will only ever output fizz. So that's whenever a number is divisible by 3, we'll output fizz, otherwise we'll just output that number. So we don't do the buzz part yet. So again, 6 will output fizz, 15 will output just fizz, otherwise output the number. Okay, so if we're divisible by 3, in this initial Fizzbuzz 1.0, we're going to output fizz, otherwise we're just going to output the number itself. And in order to do this, let us remember some stuff from last time. We're going to use a bunch of variables, and variables are like boxes. It's a place in memory where you can store data. We're going to be storing a bunch of integers, right? So in C++, which is different from something like Python, you have to declare your variables. You have to tell the compiler, hey, I want to use a variable. It's called this. It has this particular type as well. And that's very important because the compiler needs to make space for that before the function gets called. And that is a feature of a compiled language. We need to make space for all of our variables, and therefore we need to know how big they're going to be, because you can store an integer in less memory space than a double, and we'll talk about that later in the class. So int is, again, integers, like whole numbers. Doubles are floating point numbers, and char is for characters. Okay? That is the idea for all of those. And remember that you have to declare variables before you can give them values. You can also just declare them. So here's a line. You can use the comma to declare multiple things of the same type. So this declares an A and a B of both type int. So they will eventually hold whole numbers. But if you don't initialize your variable, it's what's called uninitialized. And it's just going to get filled in with whatever random memory value was there before when the program got run, because your program's not going to like clean out your memory for you. It's just going to run as fast as it can using what it had. So if you don't initialize your variables and you just declare them, you get what's called undefined behavior, which means that the values could be absolutely anything. Okay? Usually there'll be some number that's normal looking, like maybe 0, but a lot of the times they won't be. So don't assume that that's ever going to happen. Always initialize your variables, and here I am not doing that. So take a guess as to what the output of the code below is going to be, and then realize that it's never going to be all the time what you expect it to be, or your best guess. So it's quite possible that on my machine, A and B will get set to 0, just the way that memory is allocated on my particular version of my operating system with my CPU, all of this stuff. But I'm going to make this program just to see what happens. All right, let's make a new file called undefined or uninitialized vars.cpp. And I'll just take a bunch of stuff from here, all this boilerplate we'll use. So let's make 2 integer variables, a and b, and they are uninitialized. So we've declared them, but we haven't initialized them. So a and b will hold garbage memory values. Okay? And if we were to print this out now, we'd have to do this right here. So if we sum them, it'll look like this. And I like some spaces in between these, so let me highlight all of these, put some spaces around them for fun. There we go. And remember that C++ doesn't care about white space, so I can do that, and the program will still compile and run. I can also, because things are going off the screen, do that and make it slightly prettier, but again, it's not respecting any kind of indentation. C++ just doesn't care. As long as you use your semicolons and your braces to delimit things, you can put things in whatever order you want with any kind of white space, but try to make it pretty still. All right, so I'm going to compile this now. So g++ uninitialized-vars.cpp-o, and I will call it uninitialized-vars, just like that. All right, so now when I run this, we have no clue what the output's going to be. So it looks like the values for A and B here were this number, and yeah, totally, their sum is that. So these will change as the program runs. You see that? They are, like, it looks like B is always the same number, but you cannot guarantee any of these things. This is what's called undefined behavior. It works differently on different computers. So I encourage you to try this on your machine. It's going to look completely different. And so when we write diagrams for memory values, we'll make some boxes. So in this program, we made a variable called A, and we made a variable called B. And you can think of them as places in memory that hold values that are boxes. So right now, A and B are set to just random garbage memory things, and I'll draw that like this for the rest of this class. Okay? So that is uninitialized variables, fun stuff. And now remember, you can totally give those variables values. You can initialize them. You can declare and initialize all at once in one fell swoop, just like this, or you can wait a little while. You can say, hey compiler, here's a variable. I'm going to use it, it's an int. And then you can say later, a couple lines later, or just right after it, okay, now here's its value. And this is useful, this delayed initialization, especially when you're trying to get input from the user. We need a variable called x, but we don't know what it's going to be because the user is going to give that value. Okay? So it makes sense to not always immediately initialize things. It's okay. But before you use them in some way, you should always initialize your variables. And of course, you can change your variables after you've initialized them to some value. So here's a declaration and an initialization of my variable. And then we can go and change my variable to something else, just like any other language. So that is variable assignment. And of course, I'm sure you've seen this before, you can also use it on the right-hand side of the equality. You can say, all right, my variable is now going to be equal to 10 minus whatever it was before. So the right-hand side of an equal sign gets executed before the left-hand side when it assigns to it, okay? So there's some implicit ordering of operations going on here. And you can also do some weird things like this will check for equality, which is a Boolean value, but my variable is an integer. C++ can actually convert things between types, so from an integer to a Boolean, back to an integer again, and we'll talk about that later. And this is a great time to talk about the if statement in C++, because, again, we're trying to write this Fizzbuzz program. We need to check this n value. Whatever we get from the user, we need to check it and see if it's divisible by 3. If it is, we'll do something. If it's not, we'll do something else. So we need if statements. And here's how we do it in C++. Again, instead of indentation, we have these braces to talk about the body of the if statement. Okay? So if, and then a new thing for you Python programmers are these parentheses around the conditional Boolean valued expression. So if whatever inside of these parentheses is true, do everything between the braces. Okay? That's the idea. And so you use things that evaluate to true or false up here. You can also use things that evaluate to numbers, that is integers, because in C++, 0, for historical reasons, 0 evaluates to false, and any other integer value evaluates to true. So that means 0 is equivalent to true, and like things like 42 are or 0 is equivalent to false, and things like 42, -1 even, are equivalent to true in this language. So keep that in mind. You might see that on a test. All right, so here's an example if statement. So if 1 is less than 2, that's a Boolean valued statement, because this is going to check whether or not 1 is less than 2, returning true or false. It'll totally always return true in this case, so it was kind of useless. And then this will output foo if that's true. And I encourage you to always use these curly braces, even if you have a single statement inside of your if body. Because technically, you could write this. So this, like this, is equivalent to, and this is one of those do as I say, not as I do moments, because I will get away with not doing this sometimes. But you need to practice. I encourage you to practice by always including these braces. But it turns out in C++, if you only have a single statement inside of your if body, you don't have to include the braces. But this will not be fun for those of you coming from Python if you always try and do it like this from the get-go. You need to learn that this is the case, because the second you put something else here, this is actually not inside the if statement anymore because we didn't use braces. This is interpreted as a one-line body of an if statement, and your white space, remember, meant absolutely nothing. So not inside the if statement, even though you might think it is coming from Python. So I encourage you to always use those braces until you get used to this rule and the fact that white space doesn't really matter at all in C++. Okay, so try to use the curly braces when you can. And then here, this will check whether or not 2 is equal to 3, which is false, so this body will never get executed, so we'll never print out foo. Whereas here, we will print out foo always. Okay, that's an if statement. And now, I need you to think of an if condition that will detect numbers divisible by 3. Okay? Think about that. And it turns out that, well, let me show you what this % means if you've never seen it before. Right here, this %. In C++, % is the modulus operator. And then it's easier for me to type long things, so let me type this here. It returns the, for example, m mod n divides m by n and returns the remainder. This is giving you the remainder, okay? So to check if something's divisible by something else, maybe see, now that you know what this % means, this is just division, see if you can think of what the answer should be here. And assuming you're back now, the answer is in fact D. It's both B and C, because when something's divisible by 3, its remainder, when you divide by 3, will totally be 0. But this is also a tricky way of saying the same thing. Let's go to that. So if x is divisible by 3, I cannot spell apparently, divisible by 3, then x %3, because that's this first thing that's inside these parentheses, that, well, that becomes 0, yeah? Because its remainder would be 0 in that case. And then if I do the not sign, that exclamation point means not as well. I didn't say that either. Oh no, my computer is going very slow for some reason. Not is the not operator. So it'll take true, give you back false, and take false, give you back true. So x mod 3 will give you back 0 in this case. And then if we do the not of that, remember what 0 is it true or false in C++'s eyes? It happens to be false, so that becomes not false, which is in fact true. And that's exactly what we wanted, wasn't it? Okay, so that's why it's both B and C here. All right, moving on. So if else, let's see what's going on here. Let me just close a bunch of applications because it feels like my computer is going very slowly right now. What can I close? Not that one. Yeah, we'll come back to this. Okay. Here is an example of an if-else statement now. Is this what I want to do? No, actually before this, let's do, no, we need the else for Fizzbuzz. So after this slide, we'll do the Fizzbuzz 1.0. Okay. So here is an if statement, and then you also have an else statement that can go right after it. All right. So the idea is, if this thing is true, then execute this body. If that's not true, then go and execute this else statement. All right. So that's the same kind of else from another programming language that I'm sure you've seen before. But again, we're using braces to delimit the bodies of those things. So if x is greater than 0, we'll do these things. Otherwise, we'll do these things. That's the idea. And think about it for a second. Is there a way to write this code that I just gave up above in a more compact way? And if you stare at this long enough, you'll notice that there's some duplication here, count plus plus. That line of code is the same, even though we might not know what it does just yet. We can actually bring it out to right here after the code is done because it always gets executed, doesn't it? Okay, that's the idea there. And a brief intermission to what that means, this plus plus operator, because we know that our language is C++. This is a comedic moment. Count plus plus is equivalent to the line count equals count plus 1. All right, so it's just a shorthand for increase the variable count by 1. And so for historic reasons, this is funny because the name of the language that we're using is called C++, and it came from an older programming language called C that didn't have as many cool features, and so C got turned into C++, and that is the joke. It's better because it's bigger. It's one bigger, let's say. That is the funny fact about the language that you're currently learning. So yes, we've just made this code more compact. And all right, now let's look at this multi-way if-else statement. So this is what's going to happen here. A multi-way if-else statement is, oh, sorry, I didn't want to do this just yet. Let's stop right here. I got ahead of myself. Let's implement Fizzbuzz 1.0 now. All right, so let me highlight this to remember where I am and then go back to this slide. Now we have all the tools we need. So here's Fizzbuzz 1.0. Enter a number. All right. If it's divisible by 3, we'll output fizz. Otherwise, we'll output just the number itself. Okay. Let me make a new file now. Fizzbuzz 1.0.cpp. All right, here we go. I want to use cout, so I'll include iostream. I don't want to use std all the time, using namespace std. And then I'll make my main function, which always returns an integer, and it returns 0 if if the program executed successfully. Okay, here I am. I'm ready to go. The first thing we need to do is ask the user to enter a number. Oops. So output that, cout, enter a number, :space. And then we're going to get that number from the user. So let's make a variable for that user to enter. I'll call it n, cin that number n. So now n is initialized. After this cin statement has completed, we know that we got something from the user. And now we need to check it for divisibility, because if it's divisible by 3, so if n is divisible by 3, we need to output fizz, right? And I'll use a new line as well. Otherwise, we need to output n, because it wasn't the thing that we needed to output fizz for. All right? And now we know that checking for divisibility is as simple as saying n mod 3, checking if that's equal to 0. Okay? So now we can play this game. Oops, I definitely don't want to open that. Excuse me. There we go. So G++, Fizzbuzz 1.0 dash O Fizzbuzz. We'll call it Fizzbuzz dash 1.0, and let's run it. Enter number 1, 1. All right, 2, 2, 3. Hey, we get fizz. 5, 6, 9. I think you get the idea. So we did it. That's our Fizzbuzz 1.0. And now in order to make 2.0, we need to have this multi-way if-else statement, which involves checking some things. So these can go as long as you need them to. You can have multiple else-if statements. And the idea is if we check this first thing, if this is true, then we'll execute the body and stop. The whole if-else statement is done being executed. Otherwise, try this. Otherwise, if x is greater than 90, then we'll do this. And then if that were true, we'll do those two statements and the entire if-else, this whole multi-way thing is done with. And then otherwise, else, if none of those things were true, we'll execute this. And we're at the end, of course we're done. So that's the idea with our multi-way if-else statements. So you can have if condition 1 holds do stuff, body 1, else if condition 2 is true, then we'll do body 2. And just for the sake of example, let's give a bunch more else if statements. Otherwise, if none of those were true before, maybe this third thing is true, and if so, we'll execute body body number 3. And this can go on forever and ever and ever until you have your final else statement. So otherwise, if none of that was true before, I don't want to include those ... dots because then maybe you'll think that you need to include them. Otherwise, body, I don't know, n. I kind of do want those ... dots. Dun, 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 dun. So you can have a million if-else statements. You can have as many else-if statements as you want. And just for the sake of explaining this and making sure it's all in our heads well, only one of the bodies of the if-else, or of the multi-way if-else statement is ever executed. It's the first body whose condition evaluated to true. Yeah. So the idea is first we'll try 1. If that's true, then we'll execute body 1 and stop the whole thing. We're done. We can go start executing down here now. We're ready to go. We've executed the entire if-else statement. Otherwise, if 1's not true, let's try 2. If that's true, we'll execute body 2, and then we're done with the entire if-else statement. We can come right down here and stop. And that's the idea. So try 1. If that's not true, try 2. If that's not true, try 3. If that's not true, keep trying until you get somewhere or to the final else statement. And the first thing that's true, or in the last case where you just fall through, execute the body and stop. Only one body is ever going to get executed in a multi-way if-else statement. Okay? And if you think about this code, there's not an immediate way to output this or to write it in a more compact way because only 2 of these cases have count++. Technically, you can combine these maybe if x is greater than 100 and x is greater than 90, then do count++. And then you'll have an inner if statement because then, yeah, it doesn't really work out because you'll still be writing more code no matter what, even if you try to clean it up. I have a feeling that there's no correct answer here. There is not a real good way to write this code in a more compact way. If there was another count++ down here, then totally you could. All right, we're ready for Fizzbuzz 2.0 now. Okay, so let's go back to this game plan way up here. So if n is divisible by 3, we'll output fizz. If n is divisible by 5, we'll output buzz. If n is divisible by both, we'll output Fizzbuzz, otherwise we'll output n. Okay? So let's code this. Let's code this up right here. Here we go. So enter a number, we get n. So n is divisible by 3, we output 0. If it's divisible by 5, we'll output buzz. And I'm actually making a mistake right now, see if you can catch it. Otherwise, if n is divisible by both 3 and 5, that's 3, 0, and n is divisible by 5 is equal to 0. Then we'll output Fizzbuzz. I'll just use lowercase, because why not? And then otherwise, we'll just output the n itself. All right, now the idea is we want to run this, and I just showed you something that you may have not seen before if you hadn't read the book yet. The double ampersand in C++ is the AND statement. It combines two Boolean valued things. And then you also have the two pipes is equivalent to the OR. Okay, so you have to use these characters. You can't use AND or OR. Technically you can. I think the newer versions of C++ do, but it's not very common yet to do that. Okay, so that is Fizzbuzz 2.0, and I shouldn't have saved this because we want to keep Fizzbuzz 1.0 the way it was. So let's see if I can do that and undo far enough. Yes, I can. All right, so this is Fizzbuzz 2.0. .cpp. And this is the final good version. Let's make sure that we didn't do anything wrong. I guess we wanted some capitals. Okay, let's include our capitals. Why not? And okay, so the idea is we can enter 1, C1. Yeah, let's go back and change these 1s to 2s. There we go. Now we're compiling. /Fizzbuzz 2.0, please. And now we'll enter a number 1, C1. Let's enter 9, because that's divisible by 3, right? We should see Fizz. If we enter 5, we should see Buzz, or even 10, we should see Buzz. All right, now if we enter 15, we should see Fizzbuzz, right? Because it's divisible by both 3 and 5. But we only see Fizz. So the issue here was the way that the if-else statement gets executed. Remember, it's the first thing that's true, and if it's divisible by, if a number is divisible by 15, well then of course it's going to be divisible by 3 as well. That's a tongue twister. Okay, so this should not be first. We should have the most restrictive thing first, and that is this statement. Okay, let's perform some surgery here. First do this, then we can try 3, then we can try 5. Then, if none of those are true, we do this one. All right, now let's see if that works. Recompile, because we changed the program, we have to recompile it. 1, 3, 5, 15, Fizzbuzz. Because now, this is the first thing that's tried. It's the most restrictive thing, and that's why we want to put it first. Okay. Now, this is not quite Fizzbuzz 2.0. Okay? What we want to do for Fizzbuzz 2.0 is to take arguments from main itself. So we want to be able to run the program and not ask for the number like this. Enter a number, get it through CN. Let's get it from the terminal itself so we can run the program like Fizzbuzz 2.0 /Fizzbuzz 2.0 1. And so we don't have to ask the user for the number. We get it because it's being called with that from the main function. So the idea is main is a function. It can take arguments as well. It takes some special arguments. They have to be this. So in C++, you have two options for your main function. For the types of your main function. It can either be this, option 1, that we've been using, int main, nothing. Option 2 is int main, int something, and then char, get ready for this, star, some other name, and then these two brackets mean array. Okay, that is your second option, and customarily we call these two variables argc and argv. They have to be in this order. Okay, so now let me say what these mean. Argc stands for argument count. It's the number of arguments that you gave to main. I should be doing a multi-line if comment, shouldn't I? Let's do it now at least. Let's get rid of those. Let's make a multi-line comment. That's easier for me now. All right, argument count. It's the number of arguments, space separated, that you use when you, let's put it here, run your program from the terminal. Okay, and I'll give some examples after we try it out. And then argv stands for argument vector, and it's the contents of your arguments. Okay, so let me first comment out this entire program that we just wrote. We know it's correct. It's going to be fine. The one thing we need to do is get rid of this enter number thing. So let's do that now. And now let's make our types here. Okay? So int argc char star argv brackets. This star can be anywhere. It can be like here, space, or there, space. I like to put it closer to the name of the variable. And then these two braces mean array, which you can think of as lists, if you're familiar with Python. So let me cout argc. Argc, whatever its value was, please tell me. And then a new line. Okay? Let me compile this now. Right now it's just going to tell me what argc was. Here it's 1. If I put some space-separated arguments, and spaces don't matter, I can put like 2 spaces here to separate them, as long as they're separated by white space. Now we know how many arguments we have, okay? I can separate them by spaces. Argc tells us how many arguments we had, and the name of the program always counts as 1. See how I just run the program once and it gets argc being 1? So the name of the program counts. The name of the program counts as 1 argument. And now, the argument vector, this argv thing here, it's a list of the text of your, it's a list of strings really, it's a list of the text of your arguments, let's say. So for example, so if I run this program, actually, let me do it way down here. For example, if I run the program as /fizzbuzz -2.0, that's my first argument, and I give, I don't know, 42, and then this isn't correct because we only want to use the first number, but let's say I give some other values called, I don't know, foo and bar. What's going to happen now is argc is set to, in this case, it will be set to space-separated things. 1, the name of the program counts. 2, 3, 4. Set to 4. And then argv will be set to the contents of those things. So it's going to be a list of strings, you can think of it as. It's really what's known as an array. But if you're familiar with Python, which I assume most of you are, it's going to essentially be a list of strings with all of those things taken out from the spaces. So that's the first one, that's the second one, that's the third one, that's the fourth one. Okay? And char star is a weird way of saying string, so it's a list with the brackets of strings. We'll learn about the different kinds of string types later. So in this case, Fizzbuzz 2.0 42 foo bar, argc is 4, and argv will be set to this list. So at index 0 we get this string, at index 1 we get this string, and at index 2 that one, index 3 we get that one. Okay? So, okay, we're almost there. See out, I don't know, argv1, and I'll put that as well. argv1, what was that? Let's compile this, because the idea is we want to be able to run this program like this. Fizzbuzz, /Fizzbuzz 2.0 space, then the number, 42. So the idea is we're going to check and make sure that argc is 2, because otherwise we don't have a number here. It's got to be at least 2. It should be exactly 2 for our cases. And argv of 1, because 0, remember, is the name of the program. All things start at index 0. That's index 0, that's index 1. At index 1 of argv, we're going to get the string that represents this argument here. Remember that every element is a string. And this will come back to bite us in just a second. Okay. Now we know these things. In order to run our program the way we want it to, we need to make sure that argc is exactly 2. If argc is not equal to 2, then cout, you should have called this program with exactly like this. /Fizzbuzz 2.0. But actually, you know what the name of the program is? It's argv0. argv0 with a space and then a number n. And that is us yelling at the user. And we want to stop the program. Let's stop the program now. We don't want to continue, because the user messed up. So let's end the main function. And there's 2 ways to do that. From the main function, we can return another number. 1, because this wasn't a successful run of the program. And this is all up to you. You can pick your favorite error code, but it shouldn't be 0 because we didn't run the program the way we wanted it to be run. You can technically return 0 here, but a non-zero number is a better answer. So return 1, and this will stop the program. This will stop the program. So let me compile like this, and then run it incorrectly. Hey man, you should have called the program exactly like this. And if I call it correctly, remember that I've commented out everything else. It'll just run and do nothing. Okay? Another way to do this, another way to end the program, returning only stops the program if it's from main, because main's that special function. If you're inside of any other function, of course, it's just going to return from that function back to whoever called you, because you were expected to answer or to compute something. There's a special function called exit that always ends the program, no matter what function you're in. Exit will stop the program no matter what function you're in, and its one argument is the exit code to use. So I can call exit with the error code 1, and this will also stop the program. And exit, this function lives in, actually I forget, I think it's the C standard library. And so we have to include that. There it is. And I think maybe if I put my mouse over it, it might see. Yeah, it knows that it exists, so it's in here, the C standard library. And now, if I run this program and call it incorrectly, again, it'll stop the program. It just called the exit function now. All right? So if that's not true, let's get the number that the user entered in argv1, because that'll be the number right here. It'll enter in argv1. We can't just do this. This won't work because the types are wrong. String versus int. remember. So instead, we'll do this. We need to convert. Let's convert argv into an integer. And this also lives in C standard library, I think. Yes, it does. So we'll say instead that we'll also say a to I. And if I put my mouse over it, you can see what it's going to do. This is a function that takes a char star, which is a string, and it's going to return an integer to us. That's exactly what we want. Converts argv1 into an integer using the a to I function. It's a library function. And so now, once we call this with argv1, it will have converted it into a number n that we can then go and use. And we don't have to get it from the user anymore. There's no need. We have it now. It's from the command line arguments. So this will call, the terminal calls your main function with these arguments. And now we already have them. We don't have to ask them from the user anymore. So now our program looks like this. Check for our correct command line arguments. Then, if everything's okay, we will call our a to I function on our first argument, our 1th argument, I guess, and do the Fizzbuzz calculation on it. We don't have to ask the user for any more input because we got it from the command line itself, which is those special arguments to the main function. Okay? All right, so let's compile it. Let's run it. 2.0. Incorrectly again. Let's give it a number. 1, outputs 1, 3, 5, 15. It does exactly what we want now. So that is the longest program we've dealt with so far. Fizzbuzz 2.0. All right. And now, I think the rest of these slides are about Git, except for the very end. So let's talk about Git for a second. The idea is you're going to be writing big programs, large, long programs in this class, and it's important to keep track of them over time as they change. Git allows you to keep track of the versions of your program. Okay? It's called a version control system. There's a bunch of different ones. Git is one of them. So it helps you track those changes in your files over time. Okay? And it lets you, for example, it works kind of like Dropbox or Google Drive, where if you change code on one machine, you give it to the cloud, and your changes will be available on every machine that you have Git installed on. Okay? So it allows you to store code on different computers and keep those, every single copy of that code in sync with one another. And you can always roll back your changes if you don't like what you did, so that's very important. Okay? So usually in this class we would encourage what's called pair programming, and I still do if you have a friend in this class and you want to work on your future labs together. Not this first one, of course, but most of the future ones you can work on with a pair programming partner. You can collaborate, and then you can share your code that way. Okay, and it also helps you keep large projects in check, so you can make things called branches that are certain, keep track of certain changes and not others. And it also lets us see, and anybody you work with, it lets us all see your code on the internet, even if we don't want to download it onto our local machine. And Git is used everywhere in the real world. If you go and work at any company, they're going to use a version control system, and the vastly most popular one is Git these days. Okay? So there's a few concepts, and let's just go over them, I guess. A repo is short for the word repository. It is like a big virtual folder. It's where all your code and all of its history is stored. So we're making Git repos to hold all of our stuff. In your labs, you will start uploading them to GitHub. It is a website that will host Git repositories that you make on your own machine. Okay? So the idea is you're going to join our Git organization. It's this one right here. UCSB-CS16-20-Nichols. You're going to join this because I have arranged with GitHub for us to have unlimited what's called private repositories, because I don't want to share. I don't want you to share your code with other people. Let me sign in here. And you will be making new repositories for each lab that you submit, okay? Because we want to see your code. So you'll say the name of your repository, like, I don't know, lab 02 with your name and things, ... The description is optional. You want to choose the private option, and you have to make sure that you're saving this under our own organization, not your own local account, okay? Our organization, because we make sure that you have access to private repositories. And then you can create a repository and start dragging files, or use this program called Git to upload them. So once you've made a repository, it looks something like this. Like, I've made this code from class. It is a folder on my computer that is also a Git repository, where I can put all of my codes, all of my code, and upload all the changes. See, like, I put this file up 5 days ago, and just 1 day ago I uploaded lecture 1. Okay, so that is the idea here. You'll make that private repo, make sure it's inside our organization, otherwise you won't be able to make a private one, unless you do some cool, like, sign up with your student account stuff. And I don't think you need to do that, it's just extra work. So once you made a repo on the GitHub website, you want to get that stuff out, and that's why it's called Git. You want to receive those files from the cloud onto your local machine. Or you want to give those files to the cloud if you've made some changes or started a Git repository. So to get a repository on your local machine, you go in your terminal to where you want it to live. Let's say you want it to live in your, I don't know, code from class folder, or your spring 2020 folder. Maybe you've made a CS16 folder. All you have to do is click this clone link and copy this fancy URL. You have to configure SSH, which we'll do eventually in your lab. But if this doesn't work for you, this SSH option, you can always click Use HTTPS, and this will always work. It'll just keep on asking you to enter in your username and password when you use it. But I've had this configured, so I'm going to use this SSH option. Feel free to use the HTTPS option as well. So to get a repository, you say git clone, and then the URL of that repository. If I were to hit enter right now, it would create a new folder with this name, this code from class, and it would start. It would take all of the changes that Git has already been given on the cloud and download them. And so, assuming I did that, it would make this folder for me called code from class. I already have it, so I'm not going to do it again. You can go inside of it, and you can see all the changes. Also, notice how when I was out here, my terminal looked like this. I have a fancy terminal, and so when I went in here, it did some cool things, saying master star. What in the world? But this is part of the Git repository. It sees that there are changes. The star means that I've made changes, and I sure have, because I've made stuff to this new lecture 2 folder. And so if you want to see what's going on inside of your Git repository, you'll say Git Status. Use this a lot. Git Status. It'll say, okay, you're on branch master. There are a bunch of different virtual folders inside of your repositories. They're called branches. The default one is called master. And it'll say, all right, your branch is up to date, so the cloud has the current version. But there are also some new files that we see. This lecture 2 folder, all of it is brand new. If you want to maybe start tracking those changes, you could use Git Add, and that's exactly what we're going to do. So right now I've made some changes in what's called my workspace. I've made local changes on my machine, and I want to give them to Git so that we remember them and see the changes. Okay? So any file that you modify, especially in your editors, it's saved in this workspace. And so right now I've made this lecture 2 folder and all the files we've done today in that workspace. And now in order to save its currently changed version locally on my own computer, I'll say Git Add, and then all the stuff I want to add to it. So I actually want to add the entire folder. So I can say Git Add dot. So Git Add everything in my folder that's changed. Git Add dot. You can also give individual file names, no problem. And now when I say Git Status again, it shows that, okay, I've staged some things. The staging area means you have told Git about all of these new files, or these files that you've changed, and you're ready to have those changes saved. So now all this stuff in green are the new files that I want to change and add. They're in my staging area now, and I want to commit them so that they're saved, and those changes I can always come back to. Okay, Git commit -m, I can say added initial lecture 2 files. And if I hit enter, it has saved those changes. It's locked them in for this stuff. And you can say Git Status again. Look at how the star went away down here. Git Status. Okay, nothing is new, but you locally know more. You have more changes than the cloud knows about. So you could say Git Push to give it to the cloud. You can also say Git Log to see all of your changes. You can use the up and down keys and then Q to stop. So I made some changes yesterday. I made these changes right now with this comment, and this is where I currently am in my master branch. I use the Q button to get out of here, the Q key to quit out of that view. So now they're all saved, and I've made these changes locally on my own computer. I want to give them to GitHub now, because right now GitHub just sees the old stuff. I refreshed the page. There's no lecture 2 folder yet. But if I say Git Push, now it might ask you for your username and password, no problem. You'll enter that. I've saved mine. But now it's uploaded all of this stuff to the cloud. Push means pushing it out of your computer onto the cloud, onto GitHub. If I refresh this page now, oh man, do I have lecture 2 and the commit that gave all this stuff. It shows all the changes. If I go into this folder, I can see all these files. I shouldn't have really added these executable files, but that's okay. And here's all the code we've done so far. Okay, so that is that. And if I've made changes, maybe my partner made changes, and I want to get them off of GitHub, I say Git Pull to pull them down onto my machine. There are no new changes right now, so this will just say up to date. Okay, so that's the idea for Git. We'll be using this in your labs. So this is just a very brief overview to give you an idea, just to give you a taste of what we're going to do. But don't you worry, if none of that made sense, you'll get plenty of practice in your labs about this. That is Git and GitHub in a nutshell. And now just some brief segues before I do a few more examples and let you go. So here are different kinds of number types in C++. We've talked about ints already. This is from your book, by the way. There are also doubles, what we talked about just briefly, and floats I talked about even more briefly. They're a special kind of floating point number. You also have long double and long and short. So integers are the standard whole number that we're going to use in this class. It uses up 4 bytes of memory, and we'll talk about what that exactly means if you've never heard of the word byte. We'll talk about that later in the class. And because it only takes a certain constant amount of memory, it's a finite amount of things that you can save in an int variable. You can only save these numbers from -2 billion something to +2 billion something. And so that's what you get for your 4 bytes of memory space for ints. For doubles, see how it's twice the memory of a float. That's why we use it. And you can store 15 digits of decimal precision, and your numbers can range between these tiny ones to these large ones. And these other ones are ones that we're not really going to use in this class, but they might be useful if you're ever going to just store very small numbers and you don't have a lot of memory on your machine. Maybe you want to use a short instead. If you want to store very, very large decimal numbers, maybe you want to try a long double. Who knows? And then some comparison operators. These are things that are mostly the same from Python. I think they might be completely the same. So in math, you test all these things. In C++, this is what it means to check for equality. Double equals, not equals, less than or equal to, and so on. So those are your comparison operators that you'll be learning about as you read the textbook. And so that brings us to the end of these slides. Let me save them so that I can give you the answers to the multiple choice questions. I want to do, I think, 2 more examples just so that you have enough information to do your next homework. Okay, so the first one is that I want to talk about this type conversion file that I've included. Let me compile it just so that I am ready to go. G++ type conversion. No, I need to get into our folder, which is leco2. G++ type conversion -o type conversion. All right, now it's ready to be run. So C++ can actually convert between types, sometimes explicitly, sometimes implicitly. For example, a integer can be converted into a double, I say d equals n, implicitly. This will convert n to be 5, the decimal 5 though, so it's like 5.0 now. but it'll just print out as 5. Booleans, we talked about that 0 integers were false-y, and then any other kind of integer was truth-y. If I convert true into an integer, it will convert it implicitly to either, it will convert it implicitly to 1 because 1 is true and 0 is false. So if you're going the other way, you're only ever going to get true translated into into 1, and false will get translated into 0 if you try to make an int out of it. Those are implicit conversions. You can also go in the opposite direction. So seeing as how int to double, you had more space in a double. Bool to int, you had more space in an int. So that's implicitly, that can be converted just fine. Doubles, though, if we take a double and try and convert it to an integer, that just won't fly. It doesn't know how to do that very well. So let's explicitly convert it into an integer by saying this static cast thing. And then you use these angle brackets, these less than or greater than the signs, to say the type that you want it to be. And then we say pi. So static underscore cast. Oops. Let me make that a different color. Then you put a type in here. It's like a function. Close it off. Then you give the value to convert. Oops. Oops. And what the static cast function does is it converts your value explicitly into the type you gave. All right. So here we're converting this pi variable into an int explicitly, and it's going to chop off the decimal places. It's not going to round it. It'll just chop them off. So 3.9, for example, would still go to 3. And again, this is something that we talked about at the very start of the class. I gave you an example of dividing 1 by like 5, some non-zero number. It actually will always become 0 because this division sign, when you put integers on both sides, because 1 is an int, 3 is an int, it'll perform what's called integer division, okay? Integer division. When you use the slash for division, and both sides of the slash are ints, you perform this thing called integer division. You lose any decimal places. And in fact, there's no rounding. The result isn't rounded. The decimals just get chopped off. So, for example, 1/3 is 0.33333 on forever, right? But when you do integer division, of course, those decimals get chopped off. So the answer, 1/3 fail, it's going to be 0, in fact. Okay? And then the solution to get double division, you need to make one of the sides of the slash a double. That's all. So as long as one side is a double, like 3.0 is a double, then it'll actually work and output your 0.3333 on forever. And it only has to be one. It can be the left side or the right side. It doesn't matter. Also, you can convert this integer that you had to a double by using the static cast again. And this will again work. We'll say 0.333 on forever. Let's see here. Also, notice that this final thing is outputting a 0. Why in the world is it doing that? Well, it's kind of a trick. This is 1.0 divided by 3, so yes, that's totally 0.3333, but we are implicitly shortening it to an integer, and again, we're going to get those decimals chopped off, so it's going to output 0. So that is type conversion in a nutshell. And let's see here. Then the very last thing I want to talk about is just a brief introduction to loops. Loops.cpp. using name space std. Into main, I don't want to get any command line arguments, so I'll just use that kind of a main function. So now let's talk about two different kinds of loops. You have your while loops and your for loops. So while loops in C++ are mostly the same as other languages. You just need to watch out for those braces. A while loop in C++ looks like this. So you have while, then you have your Boolean condition, which I'll call, I don't know, that'll be number 1. While that's true, we'll do our body, which I'll call like number 2. And the way a while loop works is it starts off testing the condition 1. If it's true, then it'll run the body once, and then go immediately back to check the condition again. And it'll keep looping like this, that's what a loop does, until it's false, at which case the loop is over. So say there's stuff after this, we start executing the stuff right after it. The loop is done at that point. And execute everything else. So that's a while loop. That's pretty simple. A brief example is counting from 1 to 10. Int I equals, let's say 1, while I is less than or equal to 10. Let's see out I and a new line, and then we'll output. We also need to increment I, so I'll say I++, because remember that's a synonym to I equals I plus 1. So if I run this, G++ loops, -o loops, we see 1 to 10. No problem there. Let's see out a couple new lines because I'm going to do a for loop now. And then we'll stop here. And we'll go back through these again next lecture, I think, as well. A for loop is a bit different in C++ as compared to in Python. In a for loop, you have a bunch of semicolon separated things. You have a initialization, you have a condition, and then you have an update. These are all separated by semicolons, which is weird. And then you have your body. And I'll call this, body. Looks like that. I'll use, I don't know, 1, 2, 3, and 4 here. So the way that a for loop gets executed is you first do the initialization once and only once, and then the condition part is kind of like a loop where you check it. If it's true, did I use a green? Yeah. If it's true, then you'll run the body, which is number 4. And then you'll go back to check the condition eventually, but actually there's a second step. Inside of the body, we'll always do the update function right after the body, the update statement, and then we'll go straight back to check the condition again. It's always condition, body, update, condition, body, update, as long as that's true. As long as that's true. Okay? And then when it's false, it's kind of like a while loop, we jump out. Done with loop. That is a for loop. It's a bit weird, and let me give you a concrete example of counting from 1 to 10 with one. You say for int I equals 1, I is less than or equal to 10, I plus plus, see out I, new line. So for loops have, it goes for initialization, condition, update. Okay, so initialization happens only once. Let me change it. Let me wait for a second before I put that comment in. Initialization happens only once, initialization happens only once, then you repeatedly check the condition, execute the body, and then execute the update statement. It's kind of like a separation of concern. It's like, all right, check this, do the body, and then always make sure to update as well. It makes it easy to iterate through these kinds of numbers, like from 1 to 10. So it just so happens that the for loop below is exactly equivalent to the while loop above. Because if you want to convert this kind of for loop to a while loop, all you have to do is take out this initialization, put it outside, then make a while loop with the same condition, then take the body, and because always the update statement happens right after the body before we go back to check the condition, you just need to put the body down here and then put the update right after it in the actual body of the while loop, and that'll actually perform the same function here. So start with y being 1, while it's less than or equal to 10, keep on outputting I and then incrementing I. That's how I'd read that. Okay? And I think that all I need to do now is show you it running, and then I will let you be free. There we go. So they're both outputting from 1 to 10, 1 to 10, and I have some more things. I have some more slides on loops in the next lecture. I just wanted to give you a taste of them right now so you can go and do your next homework. Okay? So you're ready for that now. Remember that all these whiteboard notes and all of these, all of this code from class, as well as the videos and everything, of course, are on our course website. You just click on the name of the lecture. I've changed this to say link to lecture video notes and description and link to slides. So you can get the slides and also the lecture videos here, and then the whiteboard notes are right here, and then all the code that I write is right here. Okay? And remember to ask questions on Piazza, and then also come to our office hours, and your live labs are all through this link. Or this one, they're all the same. Make sure you're keeping on checking that course calendar to keep track of what's going to be coming up. And then, yeah, I think that's all I wanted to say today. So hope you're doing all right, and I will see you in the next lecture.